there's a few main, like the most important things that started it all for me. I'd like to I'd like to bring that to your attention. I'm really curious to see how you feel
Well,
about.
points?
All
Remember,
right.
mute yourself.
Yeah. All right. Okay. Well, let me start with this. Something really simple. All right. How do you hold on a second.
Just so that everyone's aware of what's going on, this guy wanted to talk to me. I think he's a flat earther. Don't know for sure, but I'm going to knock two birds out one stone. I'm going to talk to this guy and watch the Falcon 9 launch of the Jason 3 mission. So welcome all, and we'll see what happens. And hopefully I don't get like busted for copyright infringement. I don't think SpaceX does that, but we'll see what happens. But I'll just keep an eye on the comments and wait for the more important bits as we go along. And dude, you can continue whenever you're ready.
Oh, I think I lost you.
Hello?
All right. All right. So first, how do you explain? And this is a really simple concept. How do you explain a plane? Right, planes that can travel from, let's say, Los Angeles to New York City, at the same speed, and it will at the same duration as the time from New York City to Los Angeles. Right, with the globe model, we're spinning over faster than the speed of sound at the equator, east. So how does a plane travel east to west at the same speed and rate as it travels west to east? I want to know what you think about that.
I'm going to put a concept in your head, and this is all going to make sense in the end. There's obviously a highway between New York and Los Angeles, and between Los Angeles and New York. There is a road there. And I just want to get your confirmation on that, that there is a road that exists between those 2 points, correct?
Sure.
All right, good. Is the road attached to the Earth as it spins?
Indeed, it is.
Cool. So if I were to drive on that road at 70 miles an hour towards Los Angeles, and then drive on that road from Los Angeles back to New York, and I took the same route and I made the same amount of stops and I drove the same speed, would the distance or would the time traveled between those 2 points be exactly the same?
Right, it would, but we're talking about airplanes, not
Correct.
cars.
I know.
Okay, continue.
Uh, all right. So mute, please.
I'm tr-
Okay. So the reason why the time is the same between driving from New York to Los Angeles and then back from Los Angeles to New York is because the road has a 1-to-1 speed ratio between itself and the planet. Now, what if what does the plane use for its road? Well, the plane uses the atmosphere for its road. What if the atmosphere also has that 1-to-1 speed ratio between itself and the planet? Well, by the mere fact that we don't have 1,000-mile-an-hour winds every single day, blowing everything to smithereens, I think it's safe to say that the same 1-to-1 ratio that allows the trip times to be the same in a car also allow the same trip times to be the same in an airplane. It's all about atmosphere speed ratios in relation to the planet. And if you're able to match the speed with the atmosphere to the speed of the spinning Earth, the speed of the Earth becomes irrelevant in that equation.
All right, so let me understand. What you're saying is, the atmosphere is actually directly related. So the atmosphere spins with the Earth, basically, right? That's what you're saying.
Correct. The same way that that road is attached to the surface of the Earth, and which would allow you to make the same travel time between those 2 points going in either direction, it's the same exact principle with the atmosphere. Now, even though the atmosphere isn't directly connected to the Earth, that doesn't change the fact that the atmosphere still moves with the surface of the Earth. There are some variances with, wind, but it's nothing catastrophic that's going to make a 600-mile-an-hour Boeing notice any significant difference. At most, I don't know, maybe 5-10 minutes difference, if that.
All right, I can see that, but actually, I've looked into it, and even if the atmosphere were to move in direct relation with the ground itself, um, you have to consider that the atmosphere is much larger in circumference than the surface of the Earth is. So the top of the atmosphere would actually be moving at a much higher rate of speed if it was directly connected to the surface. The higher you go, the faster the atmosphere would be moving. Why should the top of the atmosphere slow down in relation to the bottom of the atmosphere just to keep up perfectly with the speed of the ground?
If you draw a straight line going from the ground to the top of the atmosphere, that sure, as you get higher up, you're going to go faster when it comes to the rotation. But to the speed of the ground, it's all going to be the same. It's all about relative speed here. If the
If the
atmosphere has a perfect relative speed with the ground, then it's going to stay with the ground. And no matter your altitude, your speed in relation to the ground will have a 1-to-1 ratio. If we're going to look at the actual dynamics of what actually matters, we need to look at that, because when you do that, it becomes apparent that the speed of the Earth's rotation becomes very, very irrelevant.
okay, I can even buy that for now. But I have a lot more to ask you just for starters, all right?
Don't worry.
Don't worry.
I'll be here all
I'll
day.
be here all day. Well, good, because I'm actually really interested to see how this goes because honestly, I'm a skeptic when it comes to all things, all right? So,
That remains to be
that
seen.
remains to be seen. All right. Well, you're right. It does. All right, next thing on the list and I'm going to leave that open for now, okay? Because I don't know, I've kind of seen that disproved but we'll go with that for now. The next thing would be
Okay.
orbital motion. Okay. Orbital motions. All right, and not for nothing, but this like it's something as simple as the orbit of the Earth. Okay, at the equator, we're spinning. What is it? 1,100 almost miles an hour, which is faster than the speed of sound. How then could you stand at the North Pole and not be crushed like a soda can under, you know, a 300-pound man? If we're talking about centrifugal force at the equator, negates gravity to a certain degree, spinning that fast. Okay, but when you move up towards, as farther you get into the northern hemisphere, the less centrifugal force you have, and the greater gravity's effect would have on you. So if you're standing directly at the North Pole, you're actually moving half as fast as the hour hand on a clock, and this has been measured. And I can't say this for 100% certainty, but this is supposedly you would be spinning at the, directly at the North Pole. You'd be spinning half as fast as the hour hand on a clock. So there's no centrifugal force negating gravity. You would actually be crushed like a bug. Yet we know people stand at the North Pole all the time, if that's what you want to call it. And gravity is absolutely no different there than it is at the equator.
Gravity is different. You just can't feel it. It's a difference of 0.3%. If you do the mathematical equations, for example, force is mass times acceleration. Even flat earthers will agree about the gravitational acceleration of the Earth being 9.8 meters per second squared. So let's do a little bit of math here, and we'll figure this out together. So I have a calculator here. Let's hypothetically say I weigh 70 kilograms. So we have 70 times, what's the gravitational acceleration of Earth? 9.8 meters per second squared. We have a force in newtons of 686 newtons. So let's go ahead and compare that to the centrifugal force trying to throw you off the planet at the equator. So the one thing that we need is we need mass. So we have 70, so 70 kilograms. And now we need the R, which is the radius of the Earth, which is 6.371 million meters. All right, so this is the number that you get. Then you divide that by 4 pi to the second over t to the second, t being the time it takes for it to go around. So I'm actually going to bring up a better calculator so you can see the whole thing happen. So I use WebCalc 2.0. And I already did the math on this. It comes out to 0.3% difference between your weight at the equator versus your weight at the North Pole. Hardly a difference. So let's try this. So we have 70 kilograms, and we're going to times that by R, which is 6371000. Then we're also going to times that, put some parentheses there, by a product of 4 pi, which is this, 4 pi to the second, and then that will be divided by t. Now, how many seconds are there in a day? 86,000 something. Let's make sure that we're okay. So let's type in seconds in a day. I don't feel like doing the math on this one. How many seconds are there in a day? 60 hours, 60 minutes. Let's look at this. Equals 86,400 seconds. So let's do that. By 86,400 to the second. Basically, this is a centrifugal force equation. We get 2.35. Okay, so we did 686. So let's do 2.35 divided by 686. So you have 2.35 newtons compared to 686 newtons, aka 0.34256%. So between your weight at the equator and your weight at the poles, you would weigh 0.3% greater. So quite a crushing force, isn't it?
Well, honestly, it just seems like if you're spinning, and I don't know, I'm not going to talk about the math of it, but if you're spinning that fast at the equator and you're spinning almost nil at the North Pole, shouldn't that amount of force be a lot greater than 0.03% or whatever it is?
No, because you could actually do the mathematics yourself and figure out what it should be. And what it should be is not a crushing force. In fact, the force is so minute that you actually wouldn't be able to feel any different. You could go to the North Pole and not be crushed like a bug, and it still conform with the round Earth spinning at 1,000 miles an hour at the equator, whatever. And we know this because we can actually do the math and double check. We've calculated centrifugal force with smaller systems. And if the equation works on those smaller systems, then it can be applied to the bigger systems. And when it's applied to the bigger systems, and we also figure out, that with the mathematics that even flat earthers will agree with, that the centrifugal force trying to throw you off at the equator, it would make a difference to your weight of only 0.3% less at the equator. I mean, it's not a crushing force. It's hardly noticeable. No, it's not hardly noticeable. It isn't noticeable. So whoever told you that we should be squashed like a bug obviously didn't do their math and obviously has an agenda to push. And I can guess who it was. It probably was the Morgal, because I made a video about this very topic and it's uploaded on my channel.
All right. So, all right, what's the next thing on my list was orbital motion. All right?
Hmm. Yeah.
If if our satellite moon is spinning around us, our planet is spinning around the sun faster than the moon is, and our sun is spinning faster than the earth around the galactic center, and yet even our galaxy is spinning even or not spinning, I'm sorry, is traversing the universe at even faster rate of speed than our sun is through the galaxy. How is it that our moon can orbit the Earth and our Earth can orbit the sun without speeding up and slowing down at the exact when I've looked at a model for this. It's a lot easier when you have pictures, but if our sun is to orbit the galaxy and our galaxy is hurling through the infinite universe, then how is it that it doesn't speed up and slow down when it's directly aligned with the center? Do you understand what I'm saying?
No, I'm going to need you to
Okay.
repeat it.
All right. Let me try this in a different. Okay. Think about our moon.
Okay. Moon.
Orbiting our Earth. Okay. Now
Uh-huh.
our Earth is orbiting the sun. This
Mm-hmm.
is like the most primary pair of orbits that we have. Okay. So the moon has to actually, when the moon is between the sun and the Earth is actually going faster around the sun than the moon is around the Earth. So how how can we account for the Earth?
You muted
You
yourself,
muted yourself.
Yeah, I know. I'm using my phone right now, so
and
um,
I
And
recommend
I recommend
headphones.
headphones.
yeah. Well, we have to do this again. I'm gonna get some headphones, but all right. How do you count for the moon actually having to slow down when it's on the opposite side of the Earth as the sun, and then speed up, or I'm sorry, speed up when it's on the outside of the Earth, and slow down, moving the opposite? It actually has to halt in place for the Earth to catch up with it, just so that the orbital motions can fit, the accepted
I think
theory
you're
of
I
the
think you're
asking.
universe.
asking.
Uh, I think you're asking how can the moon orbit the Earth while simultaneously the Earth is orbiting the sun? Is that
Is that
essentially your
essentially
question?
your question?
Well, yeah, essentially it is, but because if you think about it, the moon orbiting the Earth, it really doesn't make sense to me when I think about it, because it would have to speed up to catch up to the Earth when it's on the outside, because the Earth is orbiting the sun. So essentially the moon is also orbiting the sun as well as the Earth, but as it orbits the Earth, it would have to speed up many times faster than the Earth to come all the way around the outside of the Earth, and then it would have to literally stop and actually at some points move in reverse to keep its orbit around the Earth as the Earth orbits the sun, because they're all moving through space time.
You have to keep in mind though the Earth is gravitationally dominant between the Earth and the sun. The moon is a lot closer to the Earth, and the Earth has a greater influence on the moon. So the moon is going to be gravitationally dominated by the Earth. It's really that simple. So as the Earth goes around the sun, because the Earth is gravitationally dominated not by the moon, so it needs to be gravitationally dominated by somebody else. It's the bigger sister in that mix. So what is bigger than the Earth Moon system? The sun. But in the meantime, the moon can't simply forget about the Earth. Its gravitational well is still there. It's just that its gravitational well is also in orbit around another gravitational well. And so by simply saying that, oh, there's still a sun there, well, no doubt there's still a sun there. The moon and Earth haven't forgotten about it. Both of them haven't forgotten about it at the exact same time. And the fact is that the gravitational well that within the Earth Moon system is still there. It's just the well itself is also in orbit around the sun. So if you were to actually do the math on this and see how much influence the sun is putting on the moon as much as the Earth is putting on the moon, the Earth would be the gravitationally dominant object in that system. But the system as a whole is in orbit. Imagine for a second that the system is just an object, a solid object. Now, let's imagine that system going around the sun. Same thing, no difference. Same laws of physics applies. All of a sudden, you make that system more dynamic by putting one body orbiting another. It's still the same dynamics. Nothing has changed. It's just that the gravitational well of the Earth Moon system is also in orbit around the sun, just like the gravitational well of our entire solar system is in orbit around the center of our Milky Way galaxy, around the supermassive black hole that's in the center. Same exact thing is applying with the sun and the Earth-Moon system.
Okay. All right. So how about this? How do you explain the fact that there is no parallax to the stars, right? We've been told that we are traveling through, the infinite universe or whatever it is. Well, I gotta ask you something. Do you believe in the Big Bang?
Yeah, do
Okay.
I believe in the Big Bang?
Okay. All right.
You might have to
That's
mute
fine.
yourself.
All right. No, I'm gonna continue with what I question
The
first,
answer
and
is
then I'll
yes.
mute. I know. I got that. Trust me. You said enough. But all right. So how's this then? We have seen the same stars forever on this planet, and actually, do you know about carbon dating? Because carbon dating is really unreliable. About carbon 14
We
and
don't use carbon dating to measure the Big Bang.
what do we? No, all right, but we use carbon dating to say the Earth is
Mute
millions of years
yourself.
old. All right, but I haven't asked my question yet. Go ahead.
Well, the thing is that you're talking about carbon 14 and carbon dating and rocks and this, that, and all the other stuff. That has nothing to do with Big Bang cosmology. If your question is about Big Bang cosmology, then ask it about Big Bang cosmology. If your question is about something completely irrelevant to Big Bang cosmology, then make that clear, because I'm not going to jump around on topics. We have to stick to one point at a time.
All right, I'm sorry. I have a lot that I want to get through.
Well, let's
All right.
stick with Big Bang first.
All right. Well, actually, I wanted to ask you this first before we move on,
Okay.
because this all has to do with orbital motions and stuff.
Okay.
The stars. You say you believe that we're traveling around the sun's going around the galaxy, and so forth. How is it that we see the same stars for thousands of years without any change, not even the slightest change whatsoever? I'm gonna mute. Hold on.
You're asking why there's no noticeable parallax shift, and this was a problem for early astronomers because even the closest stars are so far away. Yes, we do go around the sun, and yes, it is a pretty big circle. However, that is nothing to the trillions and trillions of miles away, even to our closest stars. The parallax reading, even with such a wide baseline, would be so small. I think it's, Ziller said it best. I think it was something like 0.00000046 degrees, and I have to wonder, how is a parallax value of that small supposed to be recognizable? So I don't, you gotta mute.
Sorry. Don't you think it's kind of convenient that there's always these. Okay, so what shape is the Earth actually? Is it pear shaped? Is it a sphere? Is it an oblate spheroid? Like which
Let me
is it?
guess.
Because
Neil deGrasse Tyson said it was a pear shape.
well, he said it. He said a lot of different things, but the only pictures we have are perfect spheres.
And that's what we would expect.
Right, but we've seen only perfect spheroid pictures of the Earth, even though now he claims that it's whatever the fuck shape
All right,
he says
mute.
it is.
Let's stick to that point.
Right, go ahead.
Oh, all right, mute. Okay, this was a post, also a question also asked by Christian Anarchist. By the way, shout out to him. Okay, he says, and I quote, this is an open forum, blah, blah, blah. So I recently investigated the claim by a flat earther about Neil deGrasse Tyson and NASA. They said that the Earth is pear-shaped. That's how dumb these NASA tards are. I found this interesting, especially since Tyson is one of my favorite scientists. So I looked at the video where he talks about it, but I don't see this shape in any of the pictures NASA posts. So I'm asking someone to explain this to me so I can have the knowledge on this compared to Jeranism and other flat earthers. Very smart move. So this is my comment to him. You should see it. And I said, if you exaggerate the proportions so that the differences are visible, then yes, the Earth is pear-shaped. But again, only if you exaggerate the proportions. This is the actual context of what Neil deGrasse Tyson was saying. See, flatheads love to take this out of context to try and make it seem like there is this discrepancy, a very dishonest tactic. When scientists want to visibly represent something to make a point, they need to make it noticeable. For example, here's an exaggerated gravity map. So let's say Neil deGrasse Tyson was speaking in the context of a gravity map. Oh, look, does that mean that the Earth is shaped like a retarded potato? No, it isn't. This is simply an exaggerated view of a gravity map. This is a representation of what we are seeing, exaggerated enough so that we can actually tell what's going on. Let's look at another one, this time dealing with elevation. So if we look at this exaggerated view, does this mean the Earth is the shape of a porcupine? No, the Earth is not a freaking porcupine just because there's a picture of it on the internet. This is an exaggerated view demonstrating or answering a certain question. And so when you have an exaggerated view of something, then yes, the Earth actually is pear-shaped. But what is the actual shape of the Earth? Like, let's say, what is the roundness between the equator and pole-to-pole circumference? Well, let's see. The equator is 40,075 kilometers in circumference. Pole to pole is 40,008 kilometers in circumference. So that means a difference of 0.17% circumference difference. This means that in reality, if you were where the Discover satellite was at the Lagrangian 1 point, the Earth would look like a perfect sphere to the naked eye. So in other words, exactly what is shown on the NASA pictures, but knowing a whole bunch of flat earthers, they just go the easier route and claim CGI.
All right. Well, how is it that no curvature can be measured? There's never been any curvature measured. There's been a lot of experiments done, even with water, which is the only surface that will hold, perfect relative to the center of gravity. On water, you cannot measure even over a distance of like 400 miles. It always remains perfectly flat. Why is that?
In what sense have we never taken measurements of the? We have. I've actually done it. I mean,
Okay.
have mute? If you have you actually seen my video of the ship disappearing over the horizon? If you know how far away that ship is, and you also know how tall that ship is, and you also know it, for example, the radius or whatever, or in fact, you can look at how far the ship is out and how far it is under the horizon, and then you can actually calculate the circumference of the Earth and actually measure the circumference directly with its curve. The way that you would do that is you're going to use the following equation. See, the way we find our distance to a tangent is the square root of r plus x to second minus r to second. Now, r is the radius of the Earth, and x is our height. Now, I know what you're saying. Oh, but we're presupposing r. True, but we can rearrange the equation to actually find r given that geometric fact. And so the way that we rearrange that equation is d to the second minus x to second over 2x equals r. And with that observation, you can actually measure the radius of the Earth. So if you were to take my my ship over the horizon video, or not even that, let's say you and a buddy decided you wanted to measure the radius of the Earth, and you did it on a clear day, preferably in cooler temperatures, of course. You would take your boat and wait until the very moment it starts to dip under the horizon. And of course, you can keep going beyond that. It just makes the math more complicated. But you wait until it just starts to dip underneath the horizon, or you do it this way. You wait until he's about halfway covered by the horizon, and then you tell him to flip a U-turn and come back. As he's coming back, wait for him to be fully visible. The moment he is fully visible, tell him to stop and then measure the distance. And there's many ways of measuring distance. I did it with speed and a jet ski. And once you do that, you then plug in the values that you observed in reality, objectively. You didn't get this secondhand from NASA or SpaceX or ULA or Boeing or any of those other companies. You didn't get the secondhand. You observed it yourself. And you know that this is a geometric fact because you can do multiple examples of it on paper, and this equation always gives you the correct answer. So you have experience with this. So you take those values, plug it into that equation, and that will give you the radius of the Earth itself, which means you just use curvature to measure the radius of the Earth. It's amazing stuff, isn't it?
Well, actually, there is an equation to measure the curvature. It's supposed to be 8 inches squared per mile.
Yeah, that's
Yeah, that's
actually a
actually a
mute.
well. Mute. All right.
Yeah, that equation is total hogwash. If I was you, I would ditch that equation. That equation comes from a book from the 1800s, which shows how much flat earthers are on the cutting edge of flat earth science these days. That equation is not going to give you the correct answer. In fact, the further out you go, the bigger of a fuck up you get with the answer that equation provides. It doesn't work.
Okay, I'll accept that. What about now? I've been doing research for months now, probably about 7 or 8 months. Okay,
Uh-huh.
everything points, in my opinion, points to a flat Earth. I cannot find one shred of hard evidence or proof. All right, now you've got math and you've got all these things, but you're trying really hard to defend the globe. I'm looking at things like, okay, what about when the sun is behind the clouds and all of a sudden you have the rays of the sun coming down, and you have like four different angles, or at least three different angles, almost 30 degrees difference from one side to the other. How does that prove that the sun is 93 million miles away when in all reality, okay, can I say I'm going to send you a picture, all right? I'm going to send a picture
I know
over
which
right now.
picture you're going to send me.
All right, it's not actually the sun. It's actually it's a picture of a amateur video. Why does NASA always exaggerate the curvature of the Earth in their videos? Why is that?
You're mute. All right, first of all, we don't use the rays of the sun to find out how far away the sun is. There
No,
is a
actually,
different.
I wasn't saying that. I was saying you
Well, I
can
know, I'm
actually
just hitting on everything.
yeah, I understand.
All
I'm
right, you
trying
got
to
to
hit
mute
on.
yourself, though.
I know. Right before I do, the picture I wanted to send you is it's a picture of an amateur video of they sent a balloon or some shit up into the atmosphere. Now you can measure the horizon. It rises to eye level and it's flat. Okay, it's flat all the way across. You can see the sun and you can see a hot spot from the sun on the surface. And if the sun is 93 million miles away, there's no way it could create a hot spot for one. And for two, at that same exact height, NASA will show a very profound curvature when these amateur videos they're showing perfectly flat horizons.
These amateur videos only go up to 100,000 feet or 120,000 feet at best. NASA, when they do booster separation, they're like at over 200,000 feet. And then you wait for a lot longer past that. And next thing you know, they're at 300,000 feet, 400,000 feet, 500,000 feet, 600,000 feet until eventually, they're over 200 miles up. It's when you're comparing amateurs to what NASA can do with rocketry, orbital capable rocketry, then no comparison can actually be made there. And if you were to look at the curvature weight, like let's say we had a camera that didn't distort at all, you would still see a curve. Now, of course, it'll be very subtle because you're a lot closer to the Earth, and the Earth is kind of massive, but it all still works together. In fact, Marty Meir did a video where he goes over the mathematics about it. Now, if you're at the beach looking out to sea, and you take a picture of the horizon, and that horizon is perfectly flat, perfectly straight, on a sphere with a radius of 6.371 million meters or so, how much of a curve are we to expect from that? So what he did was he showed that from the center of the picture to the very end of the picture, If you had a vertical pixel density of, let's say, 4,000 pixels or so, the curvature would only occupy 0.4 of a pixel, I think it was, or 0.2 of a pixel, not even a full pixel difference. So in other words, the curvature is not going to be visible in the image. And also, as far as well, that covers why the horizon looks flat to us because we're on the surface, and why it also looks, quote, flat up in these weather balloons. It doesn't look flat. If you draw a line and there's no distortion, you're going to see that there is a curve. It's very subtle, but it is there. You do see a curve. In fact, in many videos that flat earthers post, and especially the one posted by Morgao about the dog cam, you can actually tell there is a curvature because how Soy actually did, he took a frame from that, drew a straight line across the horizon, and what do you know? A curvature exists. And I can have him send you that picture after the fact, after this conversation has concluded. But as far as the horizon raising to eye level, no, that's only what you think you're seeing. At the top of Mount Everest, the horizon will be about 3 degrees below your line of sight. 3 degrees below your level line of sight. Now, if you don't have a visual reference, you're not going to see that. The only reference you have for the horizon is the horizon. So naturally, your eyes are going to dart down a bit, and you won't even notice that 3 degree difference. We're talking astronomically small numbers here. So even though it may appear as though the horizon raises to your eye level, it doesn't. It actually goes lower below your eye level the further down you go. I think even at ground level, it will be something like 0.4 degrees below your level line of sight. And you can do the math yourself if you want. It's a sine inverse rule. Sine inverse, same equation that we did last time, square root of r plus x to second minus r to second over r plus x. And do that math, and you'll actually get the degrees below your level line of sight. And I think it comes to like 0.4. I did the math before. I would have to find it for you. Or if you have time, we can do it right here, right now. Doesn't matter to me.
All right. Well, I'm far from done. So hold on.
All right. What's the next thing then?
You just give me 1 second.
Okay. In the meantime, I will tell the people watching T-minus 3 minutes to the Falcon 9 liftoff, Jason 3 satellite, and hopefully it will land on the drone ship, comically named Just Read the Instructions. Yes! SpaceX Falcon 9. The official rocket of, well, the official rocket of SpaceX, and also my official go-to rocket for spacefaring badassery. So T-minus 2 minutes, 30 seconds. Superb. And I do want to apologize to everyone watching. The audio quality is not great. That's because there is a severe echo. We will possibly have another talk, I'm sure of it, but it will be with headphones so that no echo can be heard by me and also be heard by you guys.
Yes, I will get headphones. Give me one
Headphones
more
are awesome. SpaceX Falcon 9. By the way, I just want everyone to know that the best song ever played was Custer by Slipknot, because that song is now stuck in my head. T-minus 1 minute, 30 seconds. At T-minus 1 minute.
All right. Before I move on to the next thing, I was thinking about this earlier. How do
Okay.
you what do you have to say about the whole about you can actually track every airplane with GPS. There's actually websites that track every airplane. How is it that only in the southern hemisphere all airplanes will disappear off GPS until they get back over the other land. And there's actually one case of a plane having an emergency stop in Alaska. I think it was going from Australia to somewhere in the US, but it had a emergency stop in Alaska. Not to mention these flights take much longer. You know, let me add this while I'm at it. Have you ever looked at the thermal and the what is it, like the currents of the ocean? If you look at it on a globe, they're very distorted, they're unorganized, but as soon as you modify that to a flat earth map, you can see perfect circles and everything seems to somehow make a lot more sense. But
A
the
lot
whole
more
thing,
sense in what?
well, because everything turns into a perfect circle. Every all the currents, all the you can see different like
Hold that thought.
thermal readings. All right, go
Hold that
ahead.
thought. And liftoff of the Falcon 9. It's on its way to deliver the Jason 3 satellite. Woo! And liftoff. All right, let's hope it can hit that drone ship. Liftoff Falcon 9.
How is it that NASA has never showed an actual, like, they might have showed you from the ground or maybe with
Well, you
some
just
cameras,
asked.
but
Are
you
you
never.
asking a different question now?
Well, yeah. All right. Let's stick to what I originally asked. The
All right, then
airplanes.
mute.
You remember my question with the airplanes?
Correct.
Why is it that we cannot track the airplanes in the southern hemisphere?
Well, I want to first hit on your current question, the ocean currents question. The thing with ocean currents is that with currents, if you distort it to fit a certain map, then of course it's going to be a circle because it's a circular map that you're looking at it on. You're literally forming the template for it, and it has to move itself within that template. If you apply that same template to a globe, it doesn't all of a sudden not make sense. The same things that's happening on the flat Earth map is also happening on the globe. It's just that your visual representation of what's going on, it simply looks different. Just because it looks different doesn't mean it is different. It's the same exact data points. So as far as the currents go, does that answer your question on the currents before I move on?
Well, not precisely because for some reason, you've seen a flat Earth map, I presume, and you obviously
Yeah,
have
it's the
seen
biggest load of crap.
right. I'm just, my point is that it seems to make a lot more sense with Australia being where it is. The flight times themselves, the actual duration of the flight times, is actually, it makes a lot more sense if you look at a flat Earth map because for Australia where it is on a flat Earth map as opposed to where it is on the globe, you can't even fly from Australia to, let's say, Africa, South Africa, without going through Europe. Why is that? When it should be a short 12-hour flight directly from Australia to, South Africa. Why should we go north to Europe and then back southwest to Africa if we're only 12 hours away?
It's funny how you mention Australia because, of course, I'm going to get accused of appeal to authority. Which, yeah, if he's a fucking authority, then we're all screwed. But to anyone that actually does their research on this, and separation, second stage ignition, yes, Merlin 1D vacuum engine, kicking ass, yes. All right, moving on. If you actually do the research on it, you can see discrepancies with the flat Earth model. In fact, didn't Tiger Dan already do the work for me? And he says that if you were to look at the flights and how they actually work, and how that when passengers are flying from, let's say, South Africa to Australia, that they see ice, that they see a large ice, that they're going over the Antarctic continent. When they see that, you have one of two options that it could be. It could either be the South Pole. They could either be taking a swing to the ice wall, as they call it, following that ice wall, and then dropping back down to the continent of Australia, or they have to be going up and then going over the North Pole, so that they can just say that's the South Pole, but in reality it's north, and then drop over on the flat Earth map to Australia. Unfortunately, when you do the actual measurements, because we do know that the size of that dinner plate that you think is the Earth, we know the diameter of that dinner plate, which means we can find the circumference of that dinner plate. It's a simple mathematical equation. I'm sure you know how to use pi. And when you do the math and then you do the flight times, you realize that the flight times, according to distance, they don't make sense on the flat Earth. Now, I'm just going to be brutally honest with you. I haven't done any homework on the flight times because it's irrelevant. It's irrelevant to the other things that we can observe that show that the Earth really is a spheroid.
Well, I don't think any evidence is relevant, especially when, a simple flight from Australia to South Africa should be 12 hours when in fact it's usually about 23 to 25 hours. That's pretty relevant actually when you have to take all evidence into account, especially when you're trying really hard to defend the globe. And honestly, if you can
Oh,
prove to
that's
me,
adorable.
if you
You
can
think I have to
prove to me
try?
that the globe, listen, I don't want to fight with you. I want an honest debate. If you can prove to me the globe theory with like not I don't your math is one thing, but if you can prove to me with some hard facts or evidence, then you will have converted me. But until then, I'm going to try to do the same. So
So you want me to give you some evidence? Let me ask you some questions then. I think that's only fair. Wouldn't you agree?
yes, I agree.
Good. So let me ask you something. How do you explain the fact that we actually do have two pole stars, and how does that geometrically make sense on a flat Earth, considering that with people on the close to the supposed ice wall, they could be looking in totally different directions, yet converse with each other over Skype that they're looking at the same stars, looking due south, rotating around a fixed point. How does that geometrically make sense on a flat Earth?
Well, before I even, I probably can't answer that, but I didn't even know there was two pole stars. But what I can tell you is, how is it, or what I can ask you, how is it that we can see the North Star from below the equator in the southern hemisphere? How can we see the North Star in the southern hemisphere?
Well, I thought I would ask you a question and get an answer first. I'll answer that for you. I will, yes, but I need you to answer my question first. Yes, there are two pole stars, and this is an objective fact. People south of the equator looking due south see a star rotating around a fixed point in the south. And again, this is a fact, just like people in the north can look due north and see another star rotating around a fixed point. All right, guys, this is the drone ship. Hang on, I want to see this because this is some real badass shit right here. All right, drone ship, guys. Drone ship, Falcon 9 first stage landing. See if they'll actually show it. Oh boy, this is going to be so badass. All right, hang on, guys.
Have you ever looked at any maps of the stars? Like, if you were standing somewhere up in the
Well, hang on.
all right, I'll hang on.
I think I asked you a question. While you're answering that, I'm keeping an eye on this drone ship because there's going to be a rocket booster landing soon, and I would kind of want to see that. So, with the pole star conundrum, how does that, in any way, shape, or form, make sense on a flat Earth? Considering that in the South, people can be looking into totally different directions, yet be seeing the same stars rotating around the same fixed point.
Okay, well, how can we even, you can't stand at the South Pole because there's the Antarctic Treaty. Nobody is allowed to stand at the South Pole, as you will have it called. To me, there is no South Pole. But
You don't. You
with the
don't.
Antarctic, with the
Hang on.
Antarctic Treaty in place, we can't even stand in the middle of Antarctica. So we wouldn't be able to determine whether or not what you're saying is true because we can't even go there. But what I can say is, how is it even
Dude, you do not need to go to the South Pole to see the South Pole star. You just need to be sufficiently below the equator. And, I'm surprised because I'm not at the North Pole. I'm in Florida. Yeah, I can see Polaris from my house. Does that all of a sudden mean that there's a freaking conspiracy going on? No, it's simply because that's how geometry works. Hang on, guys. Hang on. Think we're going to get something here. Second stage, engine cutoff. So the Merlin 1D vacuum engine is, I think, in orbit right now. We'll see what happens. Glitchy video. Anyway, so you do not need to go to the South Pole to actually see the South Pole stars. So, for example, if I go to, like, let's say Australia, and I have a buddy of mine who's in, let's say, South Africa, and they look due south, even though they're technically, according to your map, looking in pretty much opposite directions, they both conclusively say that, yes, we are seeing the same stars. They can compare, they can contrast, they can look at positions, and they see that it matches perfectly to what we would expect to see given a spherical Earth. So tell me how that makes sense in any way, shape, or form on a flat Earth map. And I'll give you a hint. The intellectually honest answer is that it doesn't.
All right, be that as it may, if you were to stand somewhere way up in the northern hemisphere, anywhere from Alaska and up, and you were to actually like trail the stars, map them, and see the direction that they're moving, you will not see them move relative to what you should see on a globe. I've seen this, and I mean, why is it that NASA's pictures of Earth are always very inconsistent? You can see one picture where North America is takes up way too much of the globe. Like for one example, the whole Red Bull
You mean
skydive
like
thing.
what we're seeing right
Right.
now?
Okay. Like what we're seeing right now. This is believable, but if you were to see maybe three or compared to three or four other photos that are official NASA photos or what they like to call footage of other planets, and how is it that they have such powerful internet or whatever it is that they can have photos taken from thousands of miles away and have it returned to Earth, but they don't even have this stuff on Earth yet. Another thing is like I said, if you were to map the stars somewhere way up in the northern hemisphere, you'll see straight lines. You won't see circles. Why is that? Why is it if you stand at the North Pole that you will not see a perfect circular motion of the stars?
I would advise that you keep your questions to one question at a time, because you asked me about NASA telemetry capabilities, which we also have telemetry capabilities here on Earth, I might add. But you're actually going to make me get away from this SpaceX thing, and I kind of hate you a little for it. So bear with me for. In fact, no, I'll do this. So let me go to this, click on YouTube, and then I will also go here. Let me go to my channel, because I have to wonder if you even watched any of my videos, because all of them pretty much conclusively debunk this whole flat Earth BS theory. So if I go to, I think it's Tyrannism Flat Wrong Part 3, maybe? Yes, I think it's Part 3. So let me go ahead and
I'm sorry, I have
get
to
this
say
up.
I haven't watched a lot of your videos because as soon as I found out about your channel,
All
it
right, but answer this question.
All right, go ahead.
What shape is that making? Is that a circle?
Yes, I see a circle. I do. All right.
Okay.
However,
What's right here? Are these stars moving from right to left? So hang on. So we have a right to left, and we also have a circle, and then we see the stars starting to converge towards another fixed point in which the stars rotate south. That is amazing how that works. So you have a convergence, a divergence, only for them to converge again. It's almost like the lines of a globe, how they meet in the center, spread out as soon as they get to the equator, and then combine again. And look, this image demonstrates that. You say that we can't see images of stars moving about in a circle. Yes, we can, and there's an image of it.
all right. Well, I have to ask you: have you ever done any experiments personally? Have you ever actually performed any of your, research experiments personally yourself? Have you ever done that?
Correct. Let me show you this one. This is my footage of the Falcon 9 liftoff. This is also my footage of the Atlas V liftoff. I also have this one, house hoist launch of the Atlas V 551 liftoff. This was the 401 liftoff. And this actually goes into the sun at a certain point, which demonstrates that the whole perspective sun setting is a load of bullshit. Observations repeated, ship disappearing over the horizon, countless mathematical equations that demonstrate, through geometry, or geometry, trigonometry, because, math is apparently part of the conspiracy.
Have you
And
ever seen a
here's
time lapse?
mine
I'm sorry. Have you ever
right
seen a
here.
time lapse of the sun supposedly rising over, the globe and then setting again? Have you ever seen a time lapse video of this?
I have made time-lapse videos of suns rising and setting. I've done it myself. What's your
Well,
point?
it looks surprisingly similar to the sun. Actually appears to be, you know, it appears to be a lot closer, and it also appears to be moving relative to the not the heliocentric model, but the geocentric model. It appears to be moving towards you, not actually going up and over, but actually coming towards and then moving in a circle. Just like you can actually observe this from a certain point, either in the northern or southern hemisphere, you can actually observe the sun going all the way around. You get 24 hours of daylight certain times a year, and it makes perfect sense. All right, you don't have to answer that. The real question I'd like to ask you right now
But I want
is
to answer it.
okay, go ahead.
Mute yourself. And by the way, I just want to say they didn't show the first stage landing on the drone ship, so I don't know what happened. I'll check back with this momentarily. Anyway, moving on. As far as the sun thing, on the flat Earth model, they had the sun going around the top of the disk, and myself and a gentleman by the name of Marai Ziller actually took the liberty of debunking this completely with the actual law of perspective. This is the video, 3,350 views, and there you go. So you can see all the comments and shit like that. But if you watch this video, what it demonstrates is that as the sun gets closer to us, what happens to objects as they get closer to you? They get bigger in your line of sight. So for example, if you have a car that's a quarter mile away, it's going to look like a little tiny speck. It's going to be a little dot. If you have a car that's parked right next to you, wow, it's a whole fucking car. It's huge. It's massive. It takes up a vast proportion of your visual angle. So as objects get further away from you, the smaller they get in your vision. So that is fact number one, and this is something that is objective. Now, another thing that is objective is the following equation: 2 times alpha equals 2 times the arctan of G over 2R, where G is the actual size of the object, A is the angular size of the object, and R is the distance to the object. And what you see is that if the sun were really moving in a way that matched the flat Earth model, which, is bogus in other respects, but sticking with just that, you see that the sun would have to rise at one angular size, grow to 4 times bigger in the sky at noon, and then shrink again to the same size it was when it rose. And we don't see this happening. If you have a camera where you have a proper solar filter so that you don't get false positives with, let's say, glare, which is a issue issue that resident fucktards like simulation theory like to push around as evidence. If you have a proper solar filter and you record the sun and you track the sun as it goes through the sky, you will see that it will take up the same amount in that frame. The sun will take up the same amount within that frame throughout the day. It stays the same angular size throughout the day and year. And that cannot be the case on a flat Earth. So what's that mean? Well, what does that mean? That means that the model that actually makes sense with that observation, And also with the observation given the shadows that we see on the moon, because I don't care what anyone says, the moon reflects light. It doesn't emit light. It also makes sense with a with a with a spherical Earth with a moon at 245,000 miles away, with the sun at 93 million miles away. And yes, we have measured the distance to the sun as well. In fact, Cool Hard Logic did a amazing video on it, and I highly recommend you see it. So that was the sun issue. That was the sun issue. What was the other issue you brought up? Because I know you brought sun.
Well, you just said that the moon reflects light, right? Why is it that I've seen this. You have to understand this as a fact at this point. The moon's light actually is complete opposite of the sun's light. Not for okay. First of all, was actually to if the moon was to reflect the sun's light, it would have to be either concave or flat. It couldn't reflect the sun's light as a sphere in all directions as it does. All right, and you can explain. What? Wait, just let me explain myself first. Okay, now the moon's light is actually putrid, and it is not warm. It is actually colder than the shade of the night. So the moon's light is actually colder than the shade, and this has been proven in at least 1,000 experiments. And okay, so there's that.
Citation, please.
Citation? What do you mean? You need do you need to see where this came from? Is that what you're asking me?
Well, duh. What I'm asking, what you're basically spouting two things here, and like I said, I would like for you to keep it to one point at a time. Now, let's go with the reflective thing first, and then we'll go on the temperature thing. All right? Does that sound fair?
Yes, it sounds fair. Okay, my first point was with the whole reflective thing. How can a sphere reflect light as the moon does? The moon almost reflects light as a flashlight. You can see the reflection of the moon just as you can see the hot spot of the sun. The moon, as it moves across the surface, will reflect light directly on a certain point, or not a specific point, but a small relative area to the surface. So if that was the case, it would either have to be concave or at least perfectly flat to reflect the sun almost as a mirror. The way the moon reflects light, it's almost as if it was self-illuminating, which I'm not sure if that's the case. But what I will say is an object can't reflect another object's light as the moon does if it was a sphere. And not for
Hang on,
nothing.
one point at a time.
All right, that's the first point.
All right, let's stick with that. That you're wrong. 100% you're wrong. The reason why we know it can reflect light is because of the mere fact that we can see it. If you have a ball, the mere fact that you can see that ball in your hand is because it's reflecting light. Somewhere there is some ambient light that it is reflecting. If you also have a object and you put a ball in the light behind that object, you will see that the object from the dark side will be slightly illuminated. Not a lot, but then again, the moon doesn't glow as brightly and as vividly as the sun does, giving us, our daytime. And at nighttime, even with the moon out, you can still see some stars. It's not a bright light, so it doesn't reflect a lot of light. But the mere fact that we can see it at all shows that it can indeed reflect light. And when you look at the moon itself and you see how the shadows of the moon act, those shadows are impossible. I will say that again. They are impossible on anything other than a sphere. And I will bet you my left nut that no one can mimic a picture that I have that I took myself on a flat disk with a single light source. They won't be able to do it. So the way they get around that is to try and say, oh, well, I don't know how this works. Therefore, it's actually the moon emitting light and not reflecting it. What a load of crap. If the sun is able to produce all this light on our surface, so that when we're in an airplane, we can see the ground below us and see how bright it is. At some points, pilots need to wear those aviators for a reason because it's so bright outside. if it's able to do that with the planet, and the planet is an objective spheroid, why can't it also do it to the moon? I mean, the moon is in space just like we are, the Earth is, and the moon is getting hit by the sun's light just like we are, and the same thing should be happening to the moon that's happening here. And that's exactly what we see, especially when you consider that the shape of the moon is, perfectly, or the shape of the shadows is perfectly accurate with a sphere, and the sun reflects on it, and the fact that we can see other spheres in our everyday life. The mere fact that you can see spheres shows that spheres can reflect light. If it didn't reflect light, you would have a black hole. And you're muted.
Yeah, hold on. I'm sorry. I want to show you a photo that I have. I have to find it somewhere in my phone. So, um, just continue for a minute. Then what was the next question I had? It was
Well, think,
Well,
well, think, think about it.
think about it.
Think
No,
about it.
I
Find
have
that
it.
picture.
Find that picture. Yeah, find your picture. Let me find mine. Keep people entertained for a minute. Let me find something.
All right, mute yourself. All right, so I don't know exactly what's going on with the Falcon 9 first stage. Let me check Elon Musk's Twitter. Let's see if he said anything on Twitter. Okay, so out to see tomorrow's launch attempt. Damn it, no updates. Fuck. Okay, so I don't know what's going on with the Jason 3 thing, and hang on. Okay, so they just said they're not standing upright on the drone ship. Damn it, but it's okay. Better luck next time, SpaceX. Landing on a drone ship is pretty fucking difficult. But they did deliver a payload into orbit, so Jason 3 is now in orbit around the Earth. Congratulations, SpaceX. I'm now going to X out of this. Yay. Okay, so if you're there, let's go, because we have about maybe 20 more minutes I can spend here, and then I have to go and do something. So anyway, guys, this is a conversation with a flat earther, I guess, or baller skeptic, whatever the hell he wants to call himself. Back and forth, question, answer, that kind of thing. Questions that I did not get answered.
Well, Red, I think we should really continue this another time. You said you only got 20 minutes left.
Correct.
I was not really prepared for you. I had no idea how prepared you were, but
It's amazing what a little bit research
can do. Well, okay, right, research. But have you ever actually followed? I mean, listen, dude. There's a lot of things that they can prove with numbers and theories and all this other shit. But next time we talk, and we should set this up, because next time I promise you I'll be prepared. I wasn't really ready. With headphones? Yes, with headphones, I promise. And I was not prepared for you at all this time. But next time we will have a full on, and I'm gonna be just as ready as you are next time. So be prepared for that yourself. I'm going to get my collections of. I'm going to get my pictures ready. I'm going to get my information ready.
Can't fucking wait.
I know. You're something else. You really are. But listen, um, I'd like to at least show you that why you believe what you believe is not. It has nothing to do with you as a person. It has to do with how you have what you've been led to believe. You have no real proof. You have your numbers. You have your. All right. I don't want to insult you. I really don't. But
you were unable
might even convert me.
to answer the pulsar conundrum.
There's a lot of things, dude. I have not even begun. I have not even begun yet. So let's call it quits for now. All right, because there's a lot.
Hang on. let me get something out first. So mute yourself, please. All right. The fact is that you brought a whole bunch of things to me that were supposedly able to trip me up, and you had a bunch of stuff rapid fire. This is all psyop bullshit that has been spewed by Jeranism and the Morgile and Mark Sargent and Flat Earth and other hot potatoes. This is stuff that has been spewed, literally taken out of the ass of these people and posted as fact by the mere fact that they claim it to be fact. Now, when it comes to what I've been led to believe, I've been led to believe that if you use mathematics properly and you apply it to observations that can be made in the field, that can be demonstrated to everyone, regardless of what they want to believe, that is the answer you should go with, because that is the answer that is objectively verifiable. When it comes to, what I've been believe, you also need to ask yourself the same question. What have you been led to believe? What have you been led to believe by these people who are basically, overly paranoid conspiratards that think everyone is out to get them, that want to feel special, that they know something that we don't know, because only by failing to understand the third dimension and not understanding basic mathematics can one really know the truth that the earth is flat. So let's not talk about, oh, you've been led to believe this or you've been led to believe that, because I can go on a rant just like you can. Let's let the facts speak for themselves. So the next time I talk to you, let's leave it at that.
All right. No, you're right. You are absolutely right. And like I said, next time I will come prepared. I really wasn't prepared for all of this. But
Then in that
I want to
case,
end this on a good note. You know, I've never been able to discuss this with someone as informed as you are. And as far as I've been led to believe, it wasn't an easy thing for me either, okay? It wasn't easy for me to start believing that everything I've believed my entire life was wrong, but all the evidence, okay, with that, at the risk of you thinking that I am an absolute nut job, I'm going to tell you how I came into thinking this in the first place.
I think that's irrelevant.
All right, well, maybe I don't need to tell you, but I'm going to tell you anyway. I
Okay.
actually did, okay, at the risk of you thinking I'm a nut job, but I hope we can still continue our next debate, because like I said, next time I'm not going to make it easy for you like it was this time. So, the reason and the whole reason that this happened to me in the first place was because I did a spell, all right? Now, I don't want you to think I'm crazy. I don't believe in spells either, but I did one, and the spell was for knowledge. I wanted to know the truth about stuff, and within minutes or maybe hours, I stumbled upon this whole flat earth concept. I didn't like it, and I was the same way as you were. I was like, I'm going to let these guys have it. They're idiots. But, you know, eventually I couldn't deny all the things I was seeing. So the spell, it's called blood over intent, if that helps. I did a blood over intent spell, and my intention was to know what the truth was. Well, I ended up learning about flat earth, and it seemed pretty weird to me that this would all happen, in sequence. So I started to believe the things that I was seeing. And, you know, you for some reason, Red, I still don't believe in the globe. But, maybe that can change. And maybe your beliefs can change. But I promise you one thing, next time I'm going to be ready, and you're going to have a lot more on your hands than you did this time.
And
So
again, can't fucking wait.
I know. I understand who you are. But, let's call it for next Saturday or next Sunday, because I work all week. So it's up to you. We'll do it next weekend. I promise you I'll be ready for you, and you're going to have a lot more on your hands than you did this time. So,
All right. Talk to you later then.
all right, boss. I'll talk to you later.
Peace. And that does it for this hangout. So peace out, everyone watching in the feed. I'll leave this up on my channel and have fun, I guess. But congratulations, SpaceX, on delivering a payload to orbit. Sucks about the first stage, but, it's good telemetry nonetheless. But congratulations on successfully delivering Jason 3 to orbit. And the next time you guys are in Cape Canaveral, Florida, I will be there to see with my own eyes. So peace out. Have a nice day.